If y equals kx, where k is a constant, which means just a number, no attachments, and y is 24 when x is 6, what is the value of y when x is 5? So y is kx. Let me write that out. If y is 24 and x is 6, you get k. So I'm going to change y into 24. I don't know k. I'm going to change x into 6. So in order to find k, I divide everything by 6, and that tells me that k is 4. So I can rewrite this equation right here as y equals 4x now that I know what k is. So if y is 4x and then they say find y when x is 5, all right, well, y is 4 times 5 instead of 4 times x, which means y is 20. That's it. Which of the following is equivalent to the expression above? All right, looks like we're doing a gross combining like terms problem up here. When you have parentheses, if there's nothing in front of the parentheses, you don't need them. However, if you have a negative in front of the parentheses, you distribute the negative. So in red, I'm just going to rewrite the first parentheses, x squared y minus 3y squared plus 5xy squared. And with the second parentheses, because what you have in front of it is a negative, you distribute that negative. Essentially, everything in here, you flip the sign. So this becomes plus x squared y minus 3xy squared. Let's see if I have enough space. Plus 3y squared. Ooh, that was a close one. Now we combine like terms, okay, because I'm assuming that's what's going to happen. Is there anything like x squared y? Yep, there's another x squared y, so that gives us 2 x squared y's. Yeah. Is there anything like negative 3y squared? Yep, right there at the end is positive 3y squared, so they cancel each other out. How nice is that? And then last but not least, you have, oopsies, my pen. You have 5y squared, xy squared, and negative 3xy squared, which becomes 2xy squared. And that appears to be C. Which of the following graphs best shows a strong negative association, also known as correlation, between D and T? So we have D's and T's. Remember, positive association or correlation looks like that. Negative association or correlation looks like that. And no correlation is points everywhere. So I don't see a no correlation, except for that one. You're a no correlation, probably. Either that or maybe a slight positive. But the only two negative associations that I see are A and D. A is probably going down and to the right. D is definitely going down and to the right, which means D is my strong association or my strong correlation. You would be weak because the dots, yeah, I could tell that that's negative, but the dots really aren't that close to a line of best fit that I could put here. In this case, I could definitely put a line through many of these dots and have the lines or the dots surrounding it have it make sense. That's my strong. The number of rooftops with solar panel installations in 5 cities shown in the graph above, or in this case to the left because I copied and pasted it. So I've got city A, city B, city E. If the total number of installations is 27,500, what is an appropriate label for the vertical axis? So I need to find out what this is. This is cities. So this is somehow going to be the number of installations, but it obviously goes up by a specific amount. So kind of what I should do is find out how much each of these are, add them up, and see if I can equate that to 27,500 at all. So we've got 9 right here. We've got 5 right here. We've got 6. We've got 4, and we've got 3.5. All right. 9 plus 5 is 14, plus 6 is 20, plus 20 or plus 4 is 24. So I got 27.5 going on here. All of these add up to 27.5. I'm talking about 27,000. So really what this should be is this should be numbers in the thousands. Okay, because if I were to multiply all of these numbers added together to 1,000, I get 27,500. So I want the number of installations in thousands. That should do it. That should make it work. All right, done. For what value of n is the absolute value of n minus 1 plus 1 equal to 0? This is going to be a quick one. You ready? N minus 1 living in absolute value plus 1 not in absolute value equal to 0. What I always try to do when I do these absolute values, solving absolute value problems, is I get the absolute value all by itself. We do that by subtracting 1. The absolute value of who cares equals -1. I'm done. Now, the reason why I'm done and the reason why I said who cares is the absolute value is supposed to take any number in here and make it positive. There is no such number that I can substitute into any of this so that when I take the absolute value equals -1, this is impossible, which means there's no answer. Now, the quick way to do this maybe would be plug these guys in and see which one gives you 0, and then you'll find out that none of them do. But no possible answer will make an absolute value a negative. No way. A hospital stores one type of medicine in 2 decagram containers. 2 decagram containers. Based on the information given in the box above, how many 1 milligram doses are there in 2 decagrams? Well, if 1 decagram is 20 grams, then 2 decagrams is 2 times 10, which is 20 grams. So I've got myself 20 grams. 20. Now, each 1 gram is 1,000 milligrams, and they want to know how many milligrams you've got. So 1 gram is 1,000, so 20 grams is 20 times 1,000. 20 times 1,000 is 20,000. So this one's not that bad at all. Pretty basic. No complaints here. Dunzo funzo. All right, looks like in a very roundabout way, I have A equals blah, 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 T. The formula shows the relationship between A, which is the speed of the sound wave in feet per second, and T, the air temperature. It wants us to find this and solve that guy for T. So let me write it here where I have a little bit more space. This is a 2-stepper, so nothing to lose a whole lot of sleep over. I'm going to first look at what I have. T is not by itself because I have a number multiplied to it and I have a number floating around. Always get rid of the guy that's floating around first. In this case, the way we get rid of it is we subtract it from both sides. So I have minus 1052, cross U out. A minus 1052 is now equal to T times 1.08. Now that also means that T is not by itself yet. I have to get rid of this attachment, so I'm going to divide both sides by 1.08. Like that. Very glitchy today, this thing is. But what I have now is T's all by itself, and T equals that guy. So I need a minus 1052 divided by 1.08. That's my guy. My answer is A. A pediatrician, that's a doctor for children, uses the model above to estimate the height of a boy in inches in terms of the boy's age, A, in years. So H is height, A is age in years, starting from 2 to 5. Based on the model, what is the estimated increase in inches of a boy's height each year? Well, this isn't so bad. Basically, the way you would read this equation is height is 3 inches per year plus 28.6, which means, at the age of 2, you would plug in 2, get some number, yada, yada, yada. Essentially, this problem is not that bad at all. All right, you've got your height, you have your rate, the number in front of A is your rate. It is inches per year, it looks like. The answer is 3. Not much to overthink, just that. All right, we have ourselves a system of equations that we have to solve for. What is the solution of the system of equations? So this is just a regular old problem, nothing fancy, no SAT nuance. Taking a look at what I have, everything is mostly lined up. So I think I'm going to choose elimination for this one right here. So I'm going to rewrite the top equation, 3x plus 4y. What I have to be careful of is, although it's mostly lined up to match the top, it's not completely lined up. I have to swap the negative x and the positive 2y. So this is now negative x, positive 2y equals negative 19. Now, the way I'm going to approach this is I like to make one of my variables a positive coefficient and one of them the same, but the negative, the opposite version coefficient. So I'm going to go with getting rid of the x's here and multiplying the bottom row by 3. Some people might multiply the bottom row by 2 and subtract, but I'd rather add my rows than subtract my rows because, I don't know, you run the risk of not dealing with negatives as much, less things to mess up. So if I multiply the bottom by 3, the top does not change. I still have 3x plus 4y equals negative 23. The bottom row, multiplying everything by 3, becomes negative 3x, positive 6y equals negative 57. All right. Add the two rows. The x's cancel out. That becomes 10y, and that becomes negative 80. Divide everything by 10. Divide everything by 10. That is an 80, not an 81. I know that 0 looks bad, but I swear it's an 80. Y equals negative 8. Now, looking at the options, I have my answer already. Okay? Have my answer already. But I'm just going to go one step further to make sure I'm supposed to get what I get. You take one of the original equations, you plug in negative 8 for y. So it really doesn't matter which equation I use. I'll use, I don't know, the bottom one. 2 times negative 8 minus x is going to equal negative 19. 2 times negative 8 is negative 16. Negative 16 minus x equals negative 19. Add 16 to both sides. Add 16 to both sides. Cross u out. Negative x equals negative 3. Now be careful. Negative x equals negative 3. But I'm not solving for negative x. I'm solving for positive x. So if negative x is negative 3, then positive x is positive 3. And there's my x. There's my y. I end up with the point 3, negative 8. The answer is B. John runs at different speeds as part of his training. The graph shows his target heart rate at different times during his workout. On which interval is the target heart rate strictly increasing, then strictly decreasing? So basically, if you look at, like, let's just say this section right here, you're increasing, the heart rate stays the same, and then you're decreasing. That's not what they want. They want increasing and then boom, all of a sudden decreasing. And that happens in one spot in between here and in between here, which is 40 and 60 minutes. Okay, that's it. If t is greater than 0 and t squared minus 4 is 0, what's the value of t? All right, well, this is a pretty simple solving equations type problem. I've got t squared minus 0 or 4 equals 0. I'm going to add 4 to both sides, cross u out. T squared equals 4. I have a squared in the way, so the way I get rid of a square or undo a square is I square root both sides. Now, whenever I take the square root of both sides to solve an equation, okay, I have a positive or negative that needs to tack on to the square root. So this is positive or negative 2. However, t is only going to be positive. So I'm not allowed to have the negative version here. It's just going to be positive 2. That's it. A line in the xy plane passes through the origin and has a slope of 1 over 7. All right, origin 0, 0 has a slope of 1 over 7. Which of the following points is on the line? All right, so let's draw ourselves a fakey plane. Let's draw ourselves a slope that looks like it could be 1 over 7. Remember, 1 over 7 is going over the whole rise over run concept. So we're going run. So we're going up 1 over 7. So up 1 over 7 is going to look something like this. Very shallow. Okay, so if this is 0, 0, then up 1 over 7 would give you a point of 7, 1. I almost wrote that incorrectly. 7, 1. Up 1 over 7 gives you 7, 1. If you were to do it again, up 1 over 7, maybe you have a point over here. That would be 14, 2. And so on and so forth. And going backwards, up 1 over 7, or in this case, down 1 over 7, is giving you a point that has a low x value, but not so low of a y value. Okay. Now, obviously, I got done at this part right here. I came up with my answer right away. But I wanted to keep the process going that you have a shallow slope here, which means your y value isn't going to be near as big as the x value if it's shallow. In the figure above, lines L and M are parallel. All right, let me make a little mark. And lines S and T are also parallel, so let me make those marks. If the measure of angle 1 is 35, so you're 35, what is the measure of angle 2? If you're basically given intersecting lines or transversals going on here, you're either going to get the number that they give you or a number supplementary to it. So your numbers here are either going to be 35 degrees or 180. Supplementary means they add up to 180. So 180 minus 35 degrees, which ends up being 145 degrees. So all of these angles are either going to be 35. So all these acute guys are going to be 35. And all these obtuse guys, like 2, is going to be 145. And I know the pictures, you're not supposed to look at these guys and deal the whole with the whole like pictures being drawn to scale, but look at 2. Does 2 really look like it's 70 or 55 or 35? No. So I know we're not supposed to look at pictures and estimate based off the pictures, but come on. If 16 plus 4x is 10 more than 14, all right, let me just pause right there. Hold on. 16 plus 4x is 10 more than 14 is 24. What is the value of 8x? Well, let's find the value of regular x first. Subtract 16. Cross u out. 4x is going to equal 8. Divide by 4, and x equals 2. So if x is 2, 8x is going to be 8 times 2, which is 16. All right, look at this guy. For x is greater than 3, which of the following is equivalent to 1 over blah, 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 blah. All right, so I have a fraction, and on the bottom denominator, I have a fraction plus a fraction. So what I'm probably going to want to do is combine the fractions on the bottom and find a way to reciprocate it and move it to the top and then see what happens. So that's what I'm going to do. Right now, I'm only going to focus on the denominator here. I'm not going to worry about the 1 on top. I'll deal with that at the end. So I have 1 over x plus 2 plus 1 over x plus 3. This is my denominator of the entire thing. What I want to do is I want to have least common denominators for these guys. Now, there's nothing in common. And don't be like, sure there is. There's x's in both. Great. But the least common denominator is going to be x plus 2 times x plus 3, and there's no way of getting around it. It's not as simple as maybe multiplying this guy by 3 and multiplying this guy by 2. No. I'm going to multiply this fraction by x plus 3 over x plus 3. I'm going to multiply this fraction by x plus 2 over x plus 2. So when I do that, I have x plus 3 times 1. So x plus 3 times 1 is going to be x plus 3 over x plus 3 times x plus 2 plus this guy gets multiplied to 1, so x plus 2 over x plus 3 times x plus 2. The reason why I did this is now I have common denominators and I can just keep the denominator the same and add the guys on top. So when I add the guys on top, I get x plus x, which is 2x, and I get 3 plus 2, which is 5. On the bottom, I have x plus 3 times x plus 2. So this is a FOIL problem, okay? X times x is x squared. X times 2 is 2x. 3 times x is 3x. Add them together to get 5x. 3 times 2 is 6. Now this is what I've circled here in black. Now keep in mind, that was not the original problem. The original problem was 1 over that. What this is saying is 1 divided by a fraction. Now, a very basic idea that if you have a number, we'll say 1 again, divided by a fraction, you keep the first guy, you change this to a multiply, and you flip. So dividing the fraction is the same as multiplying the reciprocal. So what I get to do here is I'm going to multiply 1 to this guy, but flipped. So if I flip it, I get x squared plus 5x plus 6 over 2x plus 5. 1 times that makes that 1 useless. And so I'm left with x squared plus 5x plus 6 and 2x plus 5. Now, if you're wondering why they gave you x has to be greater than 3, the original problem, okay, if you were to plug in certain numbers like -3, -2, you would get something that's undefined, which is not allowed. So you have to go with certain traits that say x is greater than 3 to avoid asymptotes. And that's it. If 3x minus y equals 12, what is the value of 8 to the x over 2 to the y? You know, whenever you see two equations that don't really look like they belong together, there's got to be a reason why one leads you to another. So I'm looking at this guy here. I got 8 to the x, 2 to the y. You know what? I'm going to write that 8 as something with a power of 2 because I can. 8 can be written as 2 to the third. Now, while I have 2 to the third there, I still have x on the outside of that parentheses. 2 to the y still lives there. You know what? If I have a power being taken to another exponent, multiply the exponent. So that's 2 to the 3x over 2 to the y. So now I have a 3x and I have a y just like I have over there. Wait a minute. When I divide terms of the same base, subtract the exponents. So 2 to the stuff over 2 to the other stuff is 2 to the stuff minus other stuff. So I get 2 to the 3x minus y. Oh yeah, 3x minus y is the same as 12. So this becomes 2 to the 12th. Would you look at that? Oh, how about... You know what? I had no clue that those two would end up matching to do something special. But isn't that always the way? Look at that. For the function g defined above, a is a constant and g of 4 equals 8. What is the value of g of -4? All right, so we've got two things that we have to take care of. All right, I have to find out what g of -4 is, but I have no clue what that is given the information. What I do know is that g of 4 is 8. So if g of 4 is 8, you can replace every x in here with 4. So that becomes a 4. And then you know a little bit more of this. So what I have to do is I have to find out what a is before really I do anything. So what I'm going to do is I'm going to take maybe an unnecessary step, but I'm going to write this out anyway. G of x is blah, blah, blah. So g of 4 is the same exact blah, blah, blah. But what we're going to do is replace every x with 4. So I've got 4 squared here plus 24. Now, what I also know, and I'm going to do, is I'm going to go back here. I know that g of 4 is 8. So I'm just going to turn this guy right here into 8. So what this is going to do for me is this is going to allow me to solve for a. So 8 is equal to a times 4 squared is the same thing as 16a plus 24. Subtract 24, subtract 24. That gives me -16 on the left equals positive 16a on the right. Divide both sides by 16, and a is -1. So now what I can do is, now that I know that a is -1, I can plug in -4 into this equation and get a legitimate answer. So let me do that. Let me do that over here. Hopefully I left myself enough space. We shall see. G of -4 is equal to ax squared, but I know a is -1, so I'm going to replace a with -1, or just negative. Okay, if I'm finding g of -4, x becomes -4, so I have -4 squared plus 24. Okay, I'm going to move that over. -4 squared. Now be careful here. The squared is attached to the parentheses. So if you're thinking PEMDAS thoughts, ignore that negative out there. That negative is still out there. Okay. Parentheses squared is going to become positive, so -4 squared becomes 16. And remember, that negative is just kind of hanging out. You add 24, -16 plus 24 is 8. So after all of that, the value of g of -4 is 8. A is my answer. If a over b equals 2, what is the value of 4b over a? So I'm given a fraction a over b, and I'm supposed to do something involving its reciprocal b over a. So why don't we do something about that? A over b is 2, but I'm going to write it as 2 over 1. I can do that. Why not? Which means b over a is 1 over 2. Now what I can do is I can rewrite this guy over here as 4 times b over a. What's b over a? Well, I've just found that out. It's a half. So 4, I don't know where these dots are coming from, times a half is going to equal 2. That guy. In the equations above, B and C represent the price per pound in dollars of beef and chicken, respectively. Not to be confused with respectfully, sheesh. X weeks after July 1st during last summer, what was the price per pound of beef when it was equal to the price of pound for chicken? So I want B and C to equal each other. Well, in order to do that, I need to find out what X is, because it's talking about X weeks. So if B and C need to equal each other, that means this guy and that guy has to equal each other. So I'm going to set them equal to each other. 2.35 plus 0.25x equals 1.75 plus 0.40x. So what we have is a terrible version of an equation with variables on both sides of the equal sign. I'm going to subtract out the smallest version of my variable, because that's just the way I do it. You know, you could still subtract 0.4 from both sides, x, and still be fine, but I like getting rid of the smaller version. That way, you know, it keeps my x positive. So that becomes 2.35 equals 1.75 plus 0.15x. Minus 1.75, minus 1.75, cross u out, and I'm not going off screen to find out what this is. I'm just taking a brief break because life is difficult. What you're hearing is not me typing the numbers into a calculator off screen. It's me sneezing, bless you, and we get 0.6. So 0.6 is equal to 0.15x. Divide both sides by 0.15, and you get 4. Uh-oh. Now, before you look at your answers and say to yourself, gasp, I did it wrong. No, you didn't. See, 4 represents the amount of weeks it took for these guys to match up in price. Is it asking us for how many weeks it took? No, it's asking for the price per pound of beef when it was equal. So I need to find out what B is after that 4th week. So I'm going to rewrite this guy and plug in 4. So 2.35 plus 0.25 times 4. I know that 0.25 times 4 is 1 because of, 4 quarters in a dollar, and that equals 3.35, which means it cost $3.35. Okay? Tricky. If the SATs, when they created a problem like this, what they should have done is they should have given you an option that said $4, so a lot of people would put that as their answer. But the SATs looks like they were nice on this one. Thank you, College Board. All right, this one is pretty insane. I'm not going to lie. You have a FOIL-looking problem right here, set equal to a polynomial right here. It tells you that a plus b is 8. It asks you to find 2 possible values for c. This whole thing's a mess. So this is how I approached it. Maybe it's not the best way, but this is what I did for what it's worth. I FOILed these guys out. So let's do that. I have ax times bx, which is a bx squared. I have ax times 7, so I missed that, 7ax. I have 2 times bx, so plus 2bx. And I have 2 times 7, which is 14. That's going to equal this guy, so equals 15x squared plus cx plus 14. Now, what I know is 14 on the left, 14 on the right, useless. Don't need them. Cross them out. They cancel each other out. What I also know is that a plus b is 8. This is me trying to make an underline, and it doesn't look good at all. But if a plus b is 8, that also means that a is 8 minus b, because I can subtract b from both sides. So I'm going to rewrite these two and replace a with 8 minus b. So I've got 8 minus b, bx squared, plus 7, 8 minus b, replacing a with a minus b. Then I just rewrite the rest. 2bx, that equals 15x squared plus cx. So again, I'm about to show you what I did, and it's not the best way ever maybe, but I don't know, it worked for me. Let's distribute. So I have 8 times bx squared, so that's 8bx squared. I have negative b times bx squared, so that's minus b squared x squared. Okay. I have 7 times 8 and x times 8 because I have this weird double distributed property looking thing going on right here. So 7 times 8 is 56 times x. And then I have 7 times negative b times x is going to be minus 7bx. Right next to it is 2bx, so a little bit of combining like terms will happen here. That's going to equal 15x squared plus cx. I'm going to combine these two. And the only thing that changes from the line above is me combining those two. So I have this going on. I have 56x still. And now I have minus bx equals 15x squared plus cx. So this is what I did. Again, maybe not the best way, but this is how my brain works. I have an x squared in common over here and an x squared over there. I'm going to combine, well, not combine, but I'm going to factor out the x squared so I can compare what I have in blue here to what I have in blue here. So if I bring out the x squared, and I'll actually put it out front so it's like a little easier on the eyes, I have 8b minus b squared x squared. Okay? I'm going to do the same thing here and compare it to the x over here. So if I factor out an x and put the x out front, because again, it looks easier on the eyes, that's 56 minus 5b. Make sure your 56 and negative 5b don't look exactly the same. Now, what I have on the right side is I have 15x squared, and I have cx. So again, this is how I approached it. Maybe it's not the best way ever. This is how I approached it. Once I can find out b, and maybe I can find out b, but I'm going to set these guys equal to each other. I know that this stuff, x squared, is equal to 15 x squared. So stuff equals 15. So I'm going to write that in blue. I'm going to write that right here. I have 8b minus b squared, x squared, is going to equal 15 x squared. I'm just going to leave that 15. Ignore that line. Pretend that line's not there. That looks like it is a possible factorable quadratic. So I'm going to add b squared to both sides. I'm going to subtract 8b. Look at that. Look at that. Minus 8b plus 15. And I should be able to get b minus 3, b minus 5 equals 0, which means b is 3 and 5. Why is that important? Well, I didn't do the green guy yet. I know that 56 minus 5b equals c. So I'm going to write this out in two parts. 56 minus 5b equals c. 56 minus 5b equals c. I know that b is either going to be 3 or it's going to be 5. So let's plug in 3 and see what happens. 56 minus 5 times 3 equals c. 56 minus 15 equals c. And that is 41. So it looks like c could be 41. Oh, but I have another. B could be 5. So 56 minus 5 times 5 is going to equal c. 56 minus 25 equals c. 56 minus 25 is going to be 31. So it looks like to me my two possible options for c are 41 and 31. So again, is there a faster way to do that? Yeah, probably, maybe, I don't know. But this is how it worked for me. Was it easy? No. But the SATs aren't supposed to be. So that's it. Oh, baby, look at this one. This is a train wreck. The formula above gives the monthly payment M needed to pay off a loan of P dollars R percent annual interest over N months. Which of the following gives P in terms of M, R, and N? Basically, you got this. M equals ugly fraction times P. They want you to get P all by itself. Now, I'm going to rearrange this a little bit. This is what's going to determine somebody who understands math versus somebody who doesn't. That's a terrible, terrible, terrible fraction. I'm just going to pretend it's A over B. Yeah. And here's why. My job is to get P all alone by itself. I have A over B multiplied to P. I need to get rid of that A over B, that fraction. I could divide a fraction, but instead of dividing a fraction, I am going to multiply the reciprocal. So I'm going to multiply everything by B over A, by B over A. And what that does is that allows the B up here and the B down there to cross out, the A up here and the A down there to cross out. That gives me P all by itself, and I have B over A times M. So let's see what I did here. Okay, let's learn what I have. If M equals A over B P, and I have to get P all by itself, just move that fraction, flip it upside down, and move it over there. So now P is the flipped version, the reciprocal times M. In other words, M equals fraction times P, so P is going to equal the reciprocal times M. All I have to do is just flip this upside down, which is not going to be U, is not going to be U. That guy seems to be the same exact one. That guy puts the blah, blah, blah minus 1 on top, numerator, and the blah, blah, blah times blah, blah, blah to the nth on the bottom, denominator. The answer is B. Whew. So that problem, again, is designed to scare the heck out of you. But if you understand fractions and how to solve for things involving fractions, it's really not that bad if you pretend it looks like something else. Kathy is a repair technician for a phone company. Good for you, Kath. Each week she receives a batch of phones that need repairs. The number of phones that she has left to fix at the end of each day can be estimated with the equation P equals 180 minus 23D, where P is the number of phones left and D is the number of days she has worked that week. What is the meaning of the value 108, this equation? Well, this is what I'm thinking. She starts out with 108 phones, and she takes away 23 a day. So the number of phones that she has left to fix at the end of each day can be estimated with the equation 108. So 108, if you were to say that, the day is 0 and get rid of this, you're basically saying at the beginning of everything, she has 108 phones left to fix. So Kathy will complete the repairs within 108 days. No. Kathy starts each week with 108 phones to fix. Yup. Kathy repairs phones at a rate. Nope. And rate. Nope. The rate is going to be the number in front of a variable. So she starts out with 108. Basically, you're looking at 108. You can kind of compare an equation like this to something in slope-intercept form, where this would be the slope or the rate. That would be the y-intercept. So the y-intercept is always what you start out with. And that's what we have here. All right, here we go with the word problems. On Saturday afternoon, Armand sent M text messages each hour for 5 hours. Oh, we kept track of that. So that's Armand, M text messages each hour for 5 hours. So that would be 5M. For Armand, this should be 5A. Tyrone, his friend, sent P text messages each hour for 4 hours. So that would be 4P. Which of the following represents the total number of messages sent by Armand and Tyrone? Well, you just add them up. And that appears to be C. Yeah. If x minus 1 over 3 equals k, and k equals 3, what is the value of x? Ladies and gentlemen, we just have ourselves a nice solving equations problem, nothing to overthink. All we have to do is replace that k with 3 and then solve. So I have x minus 1 over 3, and instead of equaling k, it equals 3. See? Multiply both sides by 3, multiply both sides by 3. X minus 1 equals 9. To get x all by itself, you do the opposite of minus 1, which is plus 1. And x equals 10. Bada bing. Done. Done. All right, the imaginary number I said it, the number I is the square root of negative 1. So basically, I is a square root. So you treat it like a square root when combining like terms. I'm looking at a parentheses plus a parentheses, which means both sets of parentheses are useless. If you have either nothing or a plus sign in front of the parentheses, you don't need them. So I have 7 plus 3i plus negative 8, probably should have made that minus 8, plus 9i. Let me throw that negative 8 in parentheses so it looks prettier. Now what I want to do is I just want to combine like terms. So the 7 and the negative 8 combine to make negative 1. The 3i and the 9i combine to make 12i. That's what I got, and my answer is A. A summer camp counselor wants to find a length x in feet across a lake as represented by this picture right here. The lengths represented by AB, EB, BD, and CD on the sketch were determined by 1800, 1400, 700, and 800. So let's label things out, making sure that I don't screw anything up. Of course, the word respectively, I almost said respectfully, sheesh. AB is going to end up being 1800. So let me go to AB and mark you as 1800. EB is going to be 1400. So EB is that guy right there, 1400. BD is going to be 700. So that's this guy. And 800 is going to be CD, so that's 800 right there. Now, what we're doing is we have ourselves two proportional triangles. That guy is similar to that guy, which means this is going to be a multiple of that. Now, how do I figure out what's what? Well, whenever you have these two types of shapes attached to each other, these two are going to match up. Okay, these two are going to match up, and these two are going to match up. I apologize if you're colorblind. Now, what this is telling me, looking at the information that I have, is since 700 here matches up with 1400, that this entire shape is 2 times bigger. So what I'm supposed to do is segments AC and intersect B, blah, 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 blah. They have the same measure, which tells you that they're similar. What is the value of X? X is the doubled version of DC. So since DC is 800, X is going to be 800 times 2, which is 1,600 feet. And that's it. According to the system of equations above, what is the value of x? So I have myself a standard system of equations, and I don't know, I have a video before where I do elimination. I want to do the same thing here because everything's lined up literally perfectly, but just to do something different, let me do substitution. I want to solve for x. So what I'm going to do is I'm going to take this y and have y all by itself up here so that I can plug it into the bottom equation to get my x. It kind of seems backwards that I'm starting to say like, oh, in order to solve for x, I'm going to solve that for y. But by solving this for y, I leave nothing but x's, which is what I'm going to solve for. So I have y equals, if I subtract x from both sides, I get negative x minus 9. And I'm going to take that, rewrite the bottom equation, and substitute negative x minus 9 for y. So I have x plus 2. I'm going to turn y into negative x minus 9 and continue writing that bottom equation. Now that x is all by itself, I'm going to solve for x. So I'm going to distribute, x plus, actually minus 2x, because 2 times negative x is negative 2x. 2 times negative 9 is minus 18. That's going to equal negative 25. I'm going to combine these like terms and get negative 1x. So I have negative x minus 18 equals negative 25. I'm going to add 18 to both sides, add 18 to both sides. Negative x, so let me bring it up here, is going to equal negative 7. If negative x is going to equal negative 7, then positive x is going to equal positive 7. And that's all I have to do here. Now, if you used a method where you did either elimination or substitution and found y, like y equals some number, and in fact, in this case, y looks like it would be negative 16. If you found out that y was negative 16, you would just plug it into one of these two equations and find out that x is going to equal 7 anyway. But this worked for me. I kind of knew what I was doing beforehand, and so I kind of used my little brain cheating to make it work. Dunzo! In a right triangle, one angle measures x degrees, where sine x degrees is 4/5. What is cos 90 degrees minus x? All right. If you have this fact memorized, you're done, and it takes you 5 seconds. There is a trig identity that says sine x is the same as cos 90 degrees minus x. And if that's the case, if you have that memorized, you're done. If sine x is 4/5, then cos 90 minus x is 4/5. The answer is 4/5. Circle it, call it a day. Now, let's pretend we didn't know that, because not everybody has all the trig identities memorized, and no one expects everybody to have all of those memorized. It's just one of those things where if you have it memorized, you're in luck. I want to understand from the graphical point of view. All right, so I'm going to draw what sine and cosine look like and compare them to each other. All right, so magic happens at 90 degrees, at 180 degrees, at 270 degrees, and then it repeats itself at 360 degrees. I'm going to graph sine in red here. Okay, and this is what sine looks like. Sine starts at 0, 0. It peaks out at 90 degrees, goes back to the x-axis at 180, goes down and restarts at 360. This is sine. Cosine starts out at the very peak here, crosses the x-axis at 90, okay, hits a hill there, and then starts back over at 360. So what it looks like is if I were to take sine, right, and shift it over, move it left 90 degrees, I would get cosine. Okay, so cosine seems to be 90 degrees more. So sine is going to be cos 90 minus whatever it is. So that's where this comes from. So you still get 4/5 because there's a horizontal shift, where if I take 90 degrees, scooch it over, I end up with the same exact thing. So that's how sine and cosine work out from a graphical point of view. That's how they're related. This is just a fun trig identity. I had so much fun doing it. I hope you did too. The end. If a equals 5 times the square root of 2 and 2a equals the square root of 2x, what is the value of x? All right, so a is 5 root 2, and then all of a sudden it says 2a equals blah, 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 blah. I'm just going to rewrite this second equation and substitute a with 5 root 2. So I have 2, and instead of a, I'm going to write out 5 root 2, and that's going to equal the square root of 2x. 2 times 5 times the square root of 2 means I multiply the numbers outside the square root and leave the square root alone. Okay, you're not going to do square root of 20 or anything crazy like this. So there's multiple ways that I can do this, and the way that I am going to do this, just for fun's sake, is I'm going to throw that 10 inside the square root. So I have root of stuff equals root of stuff, and the roots are useless now. So what I'll do is, in order to put 10 inside a square root, I have to square it. So basically what I'm doing, and this is just a fun little thing, a fun little fact, if I want to take the number 10 and turn it into a square root, I have to get the square root there, but do something to undo it. So that becomes a square root of 100. So what I'm going to do is I'm going to turn that square root, or that 10, into the square root of 100, multiply it by 2, which gives me 200. So the square root of 200 is the same thing as a square root of 2x, which means 200 is the same thing as 2x, divide by 2, divide by 2, and x is 100. So I did it in kind of a weird way. I'm not going to lie. But you know what? I like it. You can't stop me because I'm my own person.